Imagine a material so strong it could revolutionize the way we build, yet so light it defies expectations. University of Toronto researchers have crafted a metal composite that pushes the boundaries of what's possible. This new material, described in Nature Communications, is a game-changer for high-performance industries. The reinforced metal matrix. The composite mimics the structure of reinforced concrete, but on a microscopic level. It's a blend of metallic alloys and nanoscale precipitates, creating a unique and powerful combination. But here's where it gets intriguing: it's designed to withstand extreme heat, up to 500 degrees Celsius, without compromising its strength. The strength of steel, the weight of aluminum. In construction, steel rebar enhances concrete strength in buildings and large structures. The researchers applied this concept to metal matrix composites using additive manufacturing, 3D metal printing. This innovation unlocks properties never seen before, offering a tantalizing prospect for various industries. Lightweighting, the aerospace advantage. Steel dominates trains and automobiles, but aluminum's allure lies in its weight advantage for airplanes. Lightweighting, the art of reducing component weight while maintaining strength, is crucial in aerospace. Every gram saved translates to improved fuel efficiency. However, aluminum alloys have a weakness: they soften at high temperatures, limiting their applications. Overcoming the heat challenge. The research team's solution? A composite with a reinforced concrete-like structure. They created a mesh of titanium alloy struts, akin to rebar, using additive manufacturing. These struts are minuscule, measuring only 0.2 millimeters in diameter. The spaces between them are filled with a matrix of aluminum, silicon, and magnesium, acting as the cement. The secret to extreme strength? The real magic lies in the matrix. Alumina particles and silicon nanoprecipitates, similar to gravel in concrete, provide exceptional strength. When tested, this composite displayed a yield strength of 700 megapascals at room temperature, far surpassing typical aluminum matrices. But the true revelation? At 500 degrees Celsius, it maintains a yield strength of 300 to 400 megapascals, while traditional aluminum matrices falter. Unraveling the mystery. The team's curiosity led them to discover a new deformation mechanism. At high temperatures, the composite undergoes enhanced twinning, allowing it to retain its strength. This finding highlights the potential of additive manufacturing in creating materials with unprecedented properties. The future of high-performance materials. While the material's industrial application may be some time away, it showcases the power of emerging techniques. The researchers believe that as advanced manufacturing technologies become more accessible, the cost of creating such materials will decrease, making them viable for various high-performance applications. This discovery is a significant leap towards stronger, lighter, and more efficient vehicles, opening doors to a new era of engineering.